Question 45. Prove that the wronskian of the function e raised to m1x, e raised to m2x, e raised to m3x is equal to m1 minus m2 into m2 minus m3 into m3 minus m1 into e raised to m1 plus m2 plus m3x. Are these functions linearly independent? So it's straightforward. Wronskian of x is defined as y1 of x, y2 of x, y3 of x, y1 dash of x, y2 dash of x, y3 dash of x, y1 double dash of x, y2 double dash of x, y3 double dash of x. So this becomes, we will take our y1 of x is equal to e raised to m1x, y2 of x equal to e raised to m2x, and y3 of x is equal to e raised to m3x. So that gives e raised to m1x, e raised to m2x, e raised to m3x, and differential is m1 into e raised to m1x, m2 into e raised to m2x, m3 into e raised to m3x, m1 square into e raised to m1x, m2 square to e raised to m2x, m3 square into e raised to m3x. So we can take e raised to m1, m2 and m3x outside from c1, c2, c3. So that gives w of therefore e raised to m1 plus m2 plus m3x. So we take that common out. That gives 1 m1 square, 1 m2 square, 1 m3 square. So we got our determinant. Now we have to subtract c2. C2 gives c2 minus c1 and c3 gives c3 minus c1. So we can do that. It doesn't change the determinant. E raised to m1 plus m2 plus m3x. Determinant 1, first column is unchanged, 0, 0, m2 minus m1, m2 square minus m1 square, m3 minus m1, m3 square minus m1 square. So this determinant becomes w of x equal to e raised to m1 plus m2 plus m3x into m2 minus m1 into m3 square minus m1 square minus m3 minus m1 into m2 square minus m1 square. So this is m3 minus m1. This can be written as m1 plus m2 m3 into x. Wronskian is equal to, okay, now we will take m3 minus m1 common. So m3 minus m1, if we take common, and m2 minus 1 as common from here, and this is m2 minus m1 into m2 plus m1. So what is left is here m3 plus m1 is left, minus here 1m2 plus m2 plus m1 is left. So this becomes wronskian of x is equal to e raised to m1 plus m2 plus m3 into x, m3 minus m1, m2 minus m1, and here m1 cancels out, it becomes m3 minus m2. So we got the required solution, m1 minus m2, m2 minus m3, m3 minus m1. So which is m3 minus m1, m2 minus m1, m3 minus m1. It's just rearranging the terms. We will get this. So we got the wronskian, and the question is, are these functions linearly independent? If we see, this part is not equal to 0 for any x. So, and for wx to be 0, any either m1 is equal to m2 or m2 equal to m3 or m1 equal to m3. So in situations, so if m1 is not equal to m2, not equal to m3, if this situation is in the constants m1, m2 or m3 satisfies this situation, then we can see wronskian is not equal to 0 for any x. So in such cases, wronskian is not equal to 0, and for an interval infinity to infinity, wronskian is not equal to open interval x, is not equal to 0 for any value of x, and we can say that y1 x, y2x and y3x are linearly independent given m1 is not equal to m2, not equal to m3. So this is the solution to question 45.